to start off with, now we'll first focus on data types, and then we'll move on to variables and operators. I'll show you a chart which will help you understand how the data types are structured in Java. Yes. Okay. Now, if you see the screen, now data types in Java, they are categorized into two main broad categories. One is primitive data types and one is non-primitive data types. Right? When I say primitive data types, these are something basic or very core data types. Non-primitives are something which have been derived over the period of time. So since the beginning of Java, somewhere around in 1994, from there till now, Java has evolved so much that even something called as a class is also a data type. So we can configure a class to be a data type also. So right now what we will focus is on primitive data types, and then later on, once we get into deeper, we will also see these non-primitive data types. So right now our focus is on primitive data types. In primitive, we have something called as we are categorized into numeric and non-numeric. In numeric, we have integer and floating points. When I say integers, these are nothing but numbers which have negative values or positive values or a zero. Floating points are nothing but decimals. And when we say non-numeric, we generally consider characters or text. Text are nothing but they are called as string, and we have a Boolean data type. Right. Now, to give you a list of data type that we have, so in Java we have 8 primitive data types. We have 8 primitive data types. They are starting as byte, short, int, long, float, double. Okay. Now these data types, they are numeric data types. Okay. Then we have a car or a character and a Boolean. These are non-numerics. Now, what are these data types? They define what data a variable will store. Okay. Now, a variable is something which stores data temporarily. Okay. Now, this cell that you can see on an Excel, it stores this text called as car. This is Boolean. This is short, and so on and so forth. Now, this cell is nothing but it is a variable. It's kind of a variable, and it is storing a data of the type this text. All right. Now, if I put it as a number, it will store a number. All right. Now, this differentiation is what is defined by something called as data types. So when I mention a data type as int or a byte, okay, now this tells the compiler that you have to allocate certain memory when the program is executed, okay, which will store data based on the data type. That means if it's a numeric data type, that means it will store number related data. If it's a non-numeric, it will store something called as a character or a string or a boolean. Boolean is nothing but true or false. All right. So these are 8 primitive data types which are widely used in Java programming language. Okay. Now I'll just put down these over here. Now these primitive data types, they are nothing but a keyword in itself. Compiler identifies them as a keyword. So whenever you type it as an int or say long, the color will change. If you see this code, now keywords have different colors as compared to any other text. Right? Now this is a beauty of Eclipse editor. Eclipse has an inbuilt mechanism which identifies what is a keyword, and based on that it highlights the color. But this is for an ease of handling or differentiating between data type and or a keyword and a regular text. Hence we have these colorings. Now whenever we create a variable, okay, we need to specify a data type for that variable. Always in Java, we need to provide the data type of the variable and then a variable name. Now we can terminate it using a semicolon, or we can assign a value to this variable. Now for an example, when I say data type, I can put any of these primitive data types. It can be int, let's say int, and a variable name is say a. Okay, this means that a will always contain an integer type of data. If I change it to say byte, it will contain a byte of data, and so on and so forth. That means we are defining what data the variable a will store. Okay, a is nothing but a variable which will hold some data temporarily. All right. Now a byte will store 1 byte of data. Right? Short shows 2 bytes of data, whereas integer shows 4 bytes of data. Okay. Now, when I say byte of data, that means so this statement, when I say int a, this is nothing but a declaration of the variable. This is called as variable declaring. Okay. Now when compiler encounters the statement, what it does is it will allocate 4 bytes of memory for the variable a. This is a. Now I'll just put it over here. Okay, this is a. That means whatever data I put, it will store in here, in this region of the memory. Similarly, the number of variables that we create, that many number of memory is allocated for that particular variable when the program is executed. Okay. Similarly, when we have a long, it stores up to 8 bytes of data. When I say 8 bytes, that means you can have the permutation combination in such a manner that it can accommodate 8 bytes of memory. Okay, to give you perspective, when I say 1 byte, let me just put range. I'll just show an example. Now this is nothing but my 1 byte. Okay, let's assume this is a memory. Okay, this is 1 byte of memory, and similarly we can have 2, 4, 8 bytes of memory. Okay, now when I say 1 byte, that means whatever data we put will be stored in zeros and ones in this area. Okay, so let's say I have a variable called as byte b, and I initialize it with the value say 5. Okay, now this is nothing but declaring and initializing the value, both at the same statement. This can also be written as byte b and b equal to 5. Okay, so this is just initializing, sorry, this is just declaring, and this is initializing the value or assigning of value to the variable b. Okay, now when I say a byte b, so this is b, and it will store 5 in binary format. So probably this would be something like 0, 1, 0, 1, and rest all would be 0. Okay, so this is the equivalent of 5 in a binary format. Okay, so these are all decimals, and what compiler will do is it will convert the decimal into binary, and hence it allocates that information in the given size of that variable. Now this size is determined by the data type. So when I say a byte, it will have 1 byte of memory allocated. If I say integer, the entire region will be allocated. Okay, so this would be something like this. Everything will be 0. Of course, this is very technical, but it's just an information that you guys should be aware about how the information is stored in a memory and how it is accessed, or rather what happens when you create variables when you declare a variable in a Java program. Okay, so a byte, short, integer, and long, they all hold, or they can store integer values. When I say integer values, that means it can be either negative values, which is going to be 1, -1, or say -2, or say -5, 50, something like that. It can hold 0, or it can hold positive values. All right. Whereas float and double, they store decimal points. when I say decimal, it is minus 1.1, or say minus 2.5, 50 minus 50.0, and so on. Okay, float and double, they hold decimal points. I'll just highlight it so that it becomes easier for me to map it. Okay, now float, it requires 4 bytes of memory, whereas double is bigger than float, or rather it is a higher version of float, and it can hold up to 8 bytes of, or rather it stores 8 bytes of memory. Okay, then we come to character. Now character is something we can put within single quotes, or we can assign a value as a character in a single quotes, like this. Okay, and boolean is true or false. Okay, so I'll just show you how it looks, how it works on the code. And so I'll use a byte b is equal to say 5, a short say f is equal to say 125. I'll put say int I is equal to say 10,000. Long L say 2, 3, 4, 5, 6, 7, 8. Okay. A float f is equal to say 3.5, and a double t is equal to say 33.5. Okay. Now there is something called as literals. Okay. When we say literals, this is a special keyword or a special letter that are applied, or that is put after certain data types. So these data types are nothing but float and long. So when you're defining any long or a float, you need to put something called as literal. Now this literal is called as f, okay, and an L. This indicates that the data which is stored is of type float. Okay, and data is of type long. By default, what happens is when you put a double or a float, it assumes that all the data type would be of type double. or in other words, all the decimal points in Java, they default to double data types. And hence, if you want to allocate lesser memory for a decimal point, we put it as a float and we put f as a literal. Okay, this is just a convention that is followed. Nothing to be concerned about how to do what. Generally, compiler will throw an error if you do not put it. So you can see, you see this. It says cannot convert from double to float, because by default all the floating points are considered as a double. Okay, now we'll just simply print them. What we'll do is we'll use system.out.println and we'll print the values of these variables. Right. Now we'll say b is equal to plus b. C to C. Sorry, there's no C. There's an S. S. That's I. D and D. Right. Now I'll just save and execute it and we'll get the output. Can you see this? So these are nothing but the way we store these values. So what we have done is, for the variables B, S, I, L, F, and D, we have assigned some values and we are printing those values on the console. Okay. Now these are nothing but these are numeric data types, and what we'll do is we'll add a couple of non-numeric as well. We say car C is equal to say A, and say a boolean B1 is equal to that's true, this is true. So we printed the character and the boolean as well. Okay. So these are the primitive data types that are widely used in Java programming language. Now,
Chirag, I have a question here.
Yes, sure, please.
Yeah, so now within this bracket, you're specifying system.out.println, and within the bracket you have having that plus sign.
Yes.
Here, I believe the plus sign is standing for concatenation, of the value that you want to display and the actual value of let's say D.
Yes, yes, absolutely. I'll come to that point. Yes, you're right.
So my question was, let's say you want to actually, use that. I mean, can you kind of have an expression so for example, let's say, can you have system.out.println and in bracket I plus I? So,
you want to add the value of I and I.
Correct. So can I use a plus sign within system.out.println in that sense, in an addition sense?
Yes. So see, now I'll just put it up over here. And what I'll do is I'll simply remove the quote and I'll just print, and I'll just run it. Now can you see this value? This is 20,000.
Yeah.
So what it did, it actually added. Now we'll come to this part also, which is something called as operators. This is nothing but an operator. All right. We'll come to this part once we finish this topic. So this are nothing but this helps us do these mathematical operations in Java. Yeah. So one more thing that I would like to explain over here is, now if you consider this, the statement, so everywhere I've used this part. Okay. So now here there are two aspects that we will know right now. Of course, we will talk about the concatenate operator just after this topic. But the system.out.println, we had discussed in the last session as well, that this statement, what it does is it prints the value that you have put on the console. Right now, if you see these values over here, there are two aspects. One is the area which is within the quotes, and there is one area which is outside the quotes. All right. What compiler does is, whatever information that you have put within the quotes, it will print as it is. Okay. It terms this as a pure static data. When I say static data, that means it's just data. That's it. Whereas anything outside these double quotes, it is considered as a part of your program. When I say part of your program, it could be a function, it could be say variable, anything. What compiler does is, whatever is within the quotes, it will not evaluate it. It will just print as it is. Whereas whatever is outside the quotes, it will evaluate it. When I say evaluate, that means it could be a function, it will evaluate the function. It could be a variable, it could evaluate that variable and print the value. Right. So we've just seen in this example, in the first statement, we printed the value of I, whereas in the second statement, what we did was we added I to I. Right? And what it did, it printed the final output, which is this 20,000. Right? Now here, I could have used the value, say, value of I. What it will do is it will print this part as it is, and it will print the value of I that we have used. See this value of I. Right? So whatever information that you put within the double quotes is printed as it is. Okay, that is only applicable in the statement system.out.println. Right? So this method, what it does is it accepts some parameters and it prints that parameter on the console. Now what this parameter is, it could be a data, it could be an information, anything, or it could be a function which will call another function and it will return back some value. We will see those also when we talk about methods, functions. But the only things right now wanted to inform you guys is, this is a data, is a static information that is put. You can put your name also, it will print as it is. Whereas this part outside the quotes is evaluated, or rather we can say it is processed, and then you will get the output. Okay. Now coming back to the data types. So data types. I'll just copy this part. How? Yes. Okay, so we have the data type, and this is nothing but a variable. Okay, this is a variable, and then using an operator. Now this is also an operator, as we have this plus sign. Okay, this is an operator called as equal to, which assigns a value 5 to the variable b, and b is of type byte. Okay, so that's how we call it, or that's how the fundamental works in Java. So we have a byte b, and the value of byte b is 5. Okay, now this variable, as I said, that this is a variable, it can hold any data. It can it can store any temporary data. Okay, there are certain naming conventions that is followed, or there are certain rules that are followed for Java when it comes to variables and naming these variables. Now Java, it's in itself, it's a case sensitive language. All right, when I say case sensitive, that means I can write a b and say byte b, and they both are two different variables. Okay, a b, a small b or a capital B, they are two different variables, or they are two different entities altogether. That means variable names are also case sensitive. Okay, one of the convention of variable naming is that it should start with, generally should start with a letter, or it can start with an underscore or a dollar, nothing else. Okay, we cannot have a space between, or a space in a variable name. So when I say space, that means, let me just give an example. This is boy space student. So this is not allowed. Okay, we cannot have a space for a variable name. Right? And we should always use a meaningful name for a variable. When I say meaningful, that means it should be of a kind that it is a self-explanatory. When I say self-explanatory, that means if I say a character, I want to store the character of my or the first character of my name. Right now, when I say a character of my name, we should ideally have a meaningful variable name as first character. Right now, this is a meaningful name. Now, what happens is, you can, when you read it upfront, you can judge what type of data it would store. So generally, this is a conventions that is followed in programming languages, that variable names or method names, they should be meaningful. Of course, you can have your custom names, but they should be meaningful, because it should, you can gauge or you can judge what type of data or what type of operation it may do. Having simply A1, B1 or L or F or B2 may not help you in a longer run, because if your line of codes increases to, like, say, thousands and thousands, then you will not understand what is B1. At least you will be able to determine what was this information first character. storing. We're getting it? Okay. Now, another convention that you should follow is your first letter should be a small letter. And if there are any subsequent words following this, they should be in capital. So hence I've written C as a capital. And if I want to continue it, I can say first character of my first name. Okay, so this way, generally you should mention the variable names or method names, or for that matter, class name. Can you see this class name? The class name is also that. All the subsequent words, so first letter of all subsequent words are in capital. Okay. Now, when you mention character should be generally put in single quotes. If it's a text, now text is stored in a data type called as string, and we say P2, they are always stored within double quotes. Say testing. Okay. Now, if you have observed, now string is not colored purple because it's not a primitive data type. It's a class. If you just see I have moused over on string, I'm getting an information about or help on this data type string. It says the string class represents character strings. Right? So this is non-primitive data types. Okay, so strings, we will see it later on. I mean, what operations we can do in strings and how we can play around with strings. But right now, we will just focus on the basics. Now, these primitive data types are the basic 8 ones. They have a default value assigned to them. So compiler, what it does is it assigns a default value to these primitive data types. Okay, let me come back to the screen. Yeah, I'll just erase these all parts so that it's easier for us to do. Okay, so these are nothing but bytes of memory allocated. Now, every data type has a default value, or rather every primitive data type, it has a default value. When I say default value, that means if I do not initialize or do not assign any data to this variable, to the variable of this data type, compiler will by default assign a value to it. And these values are nothing but they are 0. Okay. 0.0f and this is 0.0. For Boolean, it is false always. And for character also it is 0. But it's a character 0.
And Chirag, for long, wouldn't the default value be 0.0L?
Yeah, of course. 0. No, it is 0. No, it's not floating. Long is not floating.
Now, I believe for two of the primitive data types you had mentioned that the last letter comes. I believe one was float. There was
Yes.
one
So
more.
this is L. Yes, of course,
I
but
see.
it is not 0.0 L.
I see. Okay, okay, good. Because
Yeah.
there's no decimal in that.
Yeah, it's not a decimal.
Yeah, yeah. Okay, got it.
So this L is optional. I mean, it is not compulsory to put an L for long, but it is necessary to put an F for a floating type of data.
Okay.
Yeah. Right. Now, why is this information important? Is basically what happens is when we talk about constructor. So there's something called as constructor. We'll see what is constructor later on. When a constructor of a class is called, what the constructor does is it allocates memory to the variables. It allocates memory to the instance variables, okay, and assigns a default value to them. And when I say default values, these are the default values that are assigned to the instance variable. Now, what is instance variable? Why it is required? We will see it now. Right. So far we've learned about the data type. Okay, these are the primitive data types. We learned about a variable. What is a variable? Right. And assigning some value to it. Okay. Now this is a variable. Now a variable is nothing but a element or an entity where an object stores its value, or an object stores its state. Now in Java, everything revolves around something called as object and classes. What is an object? Object is an instance of a class. How to use this object and how to create an object, we will see it later on. But right now, our focus is on variables. Now, what we'll do is, let's save this. Okay. Now in Java, we have generally 4 types of variables. Now, when I say variable, this is int a, and I'll just put a semicolon. Now, this is a variable, and this is the data type of that variable. Okay. Now, in Java, we have something called as instance variable, or also they are known as non-static fields or non-static variables. Okay. We have class variables, or also called as static variables. We have local variables, and we have parameters. Now, what are these? First, we'll talk about class variable, then we'll see instance variable, and then we'll see local variables. A class variable is termed as a static, also known as a static variables. It is followed, or rather we term a variable as a static using a keyword called as static. It's a static int a, or we say static int a is equal to 10. Okay. Now, what happens is, or rather, what is a static variable or a class level variable is, now let's assume this is my class. Okay, say public class, say car. Okay, now in a class I have certain properties of a class, or rather I have certain properties of a car. Now, what are these properties, or what could be these properties? This property could be the color of the car. It could be the brand of the car. Let's say it could be, say, model of that car, correct? Or a lot of other parameters of a car, say, set variant of a car. Okay. Now, when I say a car, consider a car as a generic object. Okay. So when I remove all these properties, when I remove, say, color, brand, say, variant, all these, if I just remove all these factors, what I get is a simple car which has, say, a couple of doors, which has a couple of wheels, which has, say, acceleration mechanism, braking, and all these things. Right? Now, this is nothing but, you can consider it as an object. Okay. Now, when I customize it, or when I add properties to this car, what I do is I am creating an instance of this car. Okay. Now, so this, I'll just remove this area. Now, this is a box, or this is the car object. Okay. I have certain elements in this. Which are fixed. Okay, when I say fixed, that means what I have is, I have wheels, then doors, then, say, glass or glasses, say, acceleration, say, braking system, and so on and so forth. All right. Now, these are common elements or common entities of this car. All right. Now, when I add certain properties, when I say when I add properties, I'll just add a couple of stuff. Okay. When I say color, okay, this is color. Let's say this is a brand, and I'll add one more, say, variant. Now, these are wait, I'll just highlight it with some other color so that it becomes easier for us to distinguish. Okay, so the ones in yellow, they are customized. Of course, the other entities are also customized. Let's assume that only the color, brand, and variants they change depending upon a manufacturer. Okay, so what this object, when we say a class or an object, what we do is we will create something called as, we will create a class called as car. Okay, and all the manufacturers will customize it for their needs. Okay, so this becomes car of say Maruti, this becomes say Honda, and this becomes for say Hyundai. Okay, Maruti may have a different color, different brand, and say a different variant altogether, whereas Honda may have something different, and for that matter Hyundai may have something different. Okay, what I'm doing is I'm trying to create an instance of the class car. Okay, so this is one main copy. I'm a main program. I'm just trying to create a virtual instance of that main program into say Maruti, Honda, or Hyundai. Okay, so these are nothing but they are instances. Okay, they are instances of the class car. All right, now when I talk about say a static variable, okay, when I say a static variable, a static variable, what happens is in Java, all the instances will get the same value of the static variable or same value of the class variable across all the instances. Okay, now when I say same values, that means say wheels is equal to 4. Okay, all the instances will have the same value. This is called as a static variable or a class variable. So now if I change the value of say wheel from 4 to say 3, everybody will get 3, or all the instances of this class will get the same value as 3. This is static variable, or we call it as class variable. Even for that matter, let's say doors, I put say doors as 4, considering it as a static variable. Every instance will get the same value. So now if I change the value of doors from 4 to say 2, everybody will get 2. Are you getting it? So all the manufacturers of a class car, when they are creating a car, an object car, what will happen is they will create 3 wheels and 2 doors, or 4 wheels and 2 doors, or 4 wheels and 4 doors. So this is nothing but we call it as a static variable or a class variable. So what happens is all the instances of the class car will have the same value or same copy of the variable. This is a static variable. Now this only happens when I put a keyword called as static. Okay, now let's come to instance variable. So we learned about class variable. Let's now talk about instance variable. When I say instance variable, what happens is we do not put a keyword called as static. So it's just a data type and a variable name. Now, every instance can have their own copy. So I can have color as say 4. I'm just giving a value right now. It could be say, so this is pink. This could be say color equal to say blue, and this is color equal to say green. Okay, this is how it works. So instance variable, when I talk about instance variable, the scope of the variable remains till the object is alive. Now this is an object of the class car, and the object name is Maruti. So this is object Maruti, this is object Honda, and this is object Hyundai. Okay, so now an instance variable will an object or an instance will have their own copy of instance variable. When I say own copy of instance variable, that means the variable defined as an instance variable or a non-static variable will have their own values. Now they will not overlap within the two instances. So we have a variable called as color, but Maruti may have a pink color or some other color, Honda may use some other color, and say Hyundai may use some other color. Hyundai may also use a pink color or a blue color, so depending upon their choice. Yeah, are you getting it? Now, let's now move our focus to local variables. What is local variables now? So we learned about say instance variable. We learned about say static variables or the class variable. Now let's focus on say local variables. Now local variables, the scope of local variables defines or is active or remains true in which in the method in which they have been declared or created. Okay, now to give you a perspective, let's assume say Honda has a new method called as automatic transmission. Okay, and it has declared, or rather it has created a variable say integer say mileage for an example. Let me not give you a mileage, we'll just give you something else. Number of gears, automatic gears, number of auto gears. Right, now this variable will always be used within the method automatic transmission. So I'll just put some curly braces so it becomes easier for you to understand. Okay, now I can have another variable, another method, say manual transmission, and there also I can use the same variable name. Okay, I'll show you. Say this now. And down, I'll create say automatic transmission, or I'll create a manual transmission. And I can use the same variable name. Okay, now you would ask me, what is the need of this? So it's just a concept that we are trying to understand, that we can use the same variable name in two different methods. Now in Java, we cannot have same variable name with the same data type or a different data types. Compiler will throw an error message. But with the concept of local variables, we can do this. Let me show you an example of how the local variables work. What I'll do is I will create an integer b and I will put some value 100. Okay. Now what I'll do is I'll create a float and I'll give the name as b and I'll put 10.5f. Sorry. Can you see? Now I'm getting an error saying duplicate local variable b. You're getting it? Now what is happening is Java cannot have a duplicate variable name. Now what I can do is I can simply put this in a method, say public void m1 m1 just a minute. Oh, sorry. My mistake. I was trying to create, but then what I'll do is I'll create outside the main method. Yes. Yeah. Now, if you see here, I've created a new method called as m1, and in that I have defined a same variable name called as b. I can put it as int also, and it will work fine. Okay. I can create another method, say public void m2, and I can again have an int b, say 20. Okay, now if I want to print all the values, we will be able to do that. And then I'll say b in main is equal to plus b. Then b in m1 is equal to b, and b in m2 is equal to b. Okay, what I'll do is once main is called, I will call m1 and I'll call m2. Okay. So what this is doing is I have declared a method or a separate function called as m1, and there is a separate function called as m2. So there are two different methods or functions, and each of them have local variable called as b. So when I execute it, I will get value as b in main was 100, b in m1 was 10, and b is in m2 was 20. Now this b is nothing but a local variable, or rather a variable used within a method. So the scope of this variable is active till the time the method is active, or it is defined within the method itself. You getting it?
Yeah, yeah.
Okay. Now the last one is parameters. Parameters are variables which are passed to the methods. When I say variables which are passed to the methods, now these are methods. Okay. Now here I can pass a value as an variable, say integer b1. Okay. Or I can pass, say, integer b1. Okay. Now what I will do is when I call the method, I will pass value, say 10, and I will apply, pass it as 20. Okay. Now instead of this statement, what I'll do, I'll simply use int b is equal to b1, and say int b is equal to 1. I'll change the value to say 100, 1000, and 2000. Right? I'll just execute it. And I get the values. Now, if you see this variable declaration within parentheses, these are nothing but parameters, right? Or variables which have been passed to the method. So the flow of execution, how it works is, it starts from main, okay? Then it executes this statement, and when it comes to this statement, what it will do is, it will call m1 and it will pass this 1000 to the variable b1, and b1 will in turn pass it to b, and that is what we have printed. Okay, so this is how your parameters work, or this is how your local variables work. Now let's see the instance variable and the class variables. So what I'll do is I'll create an integer c, and I'll put a value, so static c, which is class variable, and put, say, value 55. Okay, and what I'll do is I'll create some instance variables, say int instance variable, put one other instance variable, say int another instance where. Okay, now to create an instance in Java, or to create an object in Java, object and instance are same. To create an instance of a class, or to create an object of a class, we require the class name to begin with. So we say variables example, say object or the instance name is equal to, using a keyword new, we say new variables example parentheses. Okay, this is how you create an object of the class, or you create an instance of a class. Using the operator new, you create an instance of the corresponding class or object of the corresponding class, right? Now I can create another instance of the same class. The only difference would be the object name. So I'll copy the statement and this becomes my object 1. Okay, now to assign a value to the instance variable, these instance variable, what we do is we use the reference of the object of that class. Now here, when you say object, obj and obj1 are the objects of this class, or the instances of the class variables example. Okay. Now to access instance variables, say instance variable or another instance where we use obj and we put a dot. When we say dot, we get a list of desired methods, available methods and available variables. We will see what are these variables and the methods that are displayed on the list in something called as access modifiers, right? But right now, using a dot, object name dot, and we provide that instance variable and we give a value to it, say 50. Similarly, I can say obj dot another instance where is equal to 20. Now these variables are part of, or these value 15 and 20, they are values of instance variable called as obj. All right, or rather I would say they are Maruti's color or Maruti's brand. Okay, similarly I'll use obj1 dot instance variable. I'll put say 25 and obj1 dot another variable and I'll put say 30. Okay, now what I'll do, I'll print these value and the class variable as well. Okay, I'll say system.out.println. Now I'll simply copy this. Obj instance variable is equal to plus obj. Same goes for obj1. obj1. Now this is obj dot another instance variable. Yep, used same. Okay, now what I'll do is I will also print the value of the class variable. So I'll use obj.class variable and I'll say obj.class variable. Same as for this statement. So obj1 and obj1. Okay. And now what I'll do is I'll simply, so let me just full screen it. Yeah. What I'll do, I'll simply execute it. Run as Java application. Can you see? Now I have class variable as 55 and class variable as 55. So both of these objects, they have the same value of 55. Whereas instance variables are different. We have 15, 20, 25, and 30. All right. Now, what I'll do is, meanwhile, in this area, I'll change the value of the class variable to say 45. Okay, I'll say obj class variable is equal to 45. Okay. Now, when I execute it, both the objects will have the same value as 45. Can you see this? This is 45. Whereas the instance variable, so of course we have not touched it, but the instance variable are different.
So Chirag, I have a question here.
Yes, please.
So you change the value of the static variable from 55 to 45 in this case.
Right.
Let's say if you had another, you repeated that same statement, just after the obj1, instantiation. So you change it, let's say, to 35 again.
This one?
Yeah, same statement, just copy that. And copy it after obj1 dot another instance where is equal to 30. Yeah, obj1, yeah, there.
Okay.
So what happens in this? Let's say change it to 35.
Okay, so you will get 35 over here. Now what happens is, as the program is executed,
Right.
Both of them will get, so what I'll do is I'll copy this before and after. Okay.
Yeah.
Let me just put this before 35, and let me just put it after 35. Okay. Now, what will happen over here is, we'll get, and after 35, the value would be 35. Can you see this? So this is before 35 was 45, and we assigned obj class variable as 35, and this is 35. Now if I print obj also, I will get the value as 35.
Okay.
Are you getting it, or there's a confusion?
No, yeah, initially there was some confusion because I had begun to think that, this is like any other variable, because we keep changing values. But now I realize that, so let's say I change the value as part of at some point, and any number of instances that are kind of created for that object, they'll keep having the same value until it is changed again.
Yes,
right?
true.
Okay.
Absolutely.
Okay, got it. Yeah.
Yep. So now if I print obj1 also, or if I just print obj instead of obj1, I will still get 35. All right, so now we've used obj1. Instead of obj1, if we have used obj also, we would have got 35.
Yeah, got it.
Yeah, so this is the beauty of instance variable. Now, just to give you one more perspective, what happens is, of course in Excel it's not possible, but when I change the value of the static variable over here, all the instances will get the same copy.
Okay.
Okay, so this becomes kind of a global entity where every instance will have the same reference. Alright?
Yeah.
Okay. So this was about the variables and the different types of variables that we have in Java. All right. Now let's move on to operators. Let me just show if we have. Yes. All right. Now these are the operators that we have in Java. Now, the simple assignment operator is using equal to. Whenever you want to assign some value, you use equal to. You say int x equal to 10 and you assign that value. You can say x is equal to y. That is also a simple assignment. If you can see this example, which says string str is equal to Java, that means we are assigning the text Java to the variable str. Okay. Now there are a couple of other operators also in Java that we can use. Right? Now these operators are nothing but addition, subtraction, multiplication, division, modulus. Now this is a special type of operator. What it does is it increments the value of that variable by 1. And when you say minus minus, what it does is it decrements the value of that variable by 1. Okay. Now these operators, I'm sure you are aware about these operators. They are simple mathematical operators. When we have two variables, let's say x and y, if you want to add, we use plus operator. If you want to subtract, we use minus. Multiplication is star and division is slash. And of course, to get the remainder, we use the modulus or the percentage sign. Right? Now plus is also used to concatenate strings. Right? Now if you can see over here in this example, originally we had string str is equal to Java. Right? Now what we did, we said str plus equal to rules. What it did is it concatenated the value of existing value of str with the new value of str with the same statement. Okay, this is nothing but concatenation. Now this can also be used like this. We have, say, string a is equal to Selenium. Okay, I can say string b is equal to, say, space. I can say string c is equal to, say, sessions. Okay, and I can simply print these values, say system dot out dot print, then sorry, this is a and plus b plus c. And then I execute it. Can you see now? This is how also you can use it. So plus operator, it is concatenating strings, or rather it is used to concatenate two strings. Yeah?
Yeah. Okay.
Okay. Okay. So double plus, what it does is it auto increments the value of a variable by 1. So when I say, now here if you can see in the example, it is x plus plus. Now originally the value of x was 10. When I say x plus plus, what happens is the value of x becomes 11. When I say x minus minus, the value of x will be 9. All right. So this is how you can use these arithmetic operators. Now, this is how you can place x plus plus or x minus minus. Right.
So Chirag, so here the increment or the decrement will always be by 1.
Yes. Now, if you want to increment or decrement it by more than 1, then you can simply use mathematical operation saying x plus 2 or x plus 1.
Okay, got it.
So this is just for simplicity. When you have double plus, it is incrementing by 1 or a decrementing by 1.
Okay.
Yeah. Okay. Right. Now, these are also, so these are extended operators. We have plus equal to that we saw, which concatenated, and it also does, so it will add the value to the existing value. All right. Now, in this example, we have, say, int x is equal to 20. Okay. When I say plus equal to 5, what it will do is it will take up the existing value of x and it will add 5 to it, which will result to 25. If it's a string, it will concatenate. Right? And same goes for subtraction, multiplication, division, and modulus. All right. Let's move ahead. Now, these are comparison or relational operators. Okay. Now, in Java, to compare two values or to check the relationship between two variables, we use these operators. Now, double equal to evaluates whether the left hand side is equal to right hand side or not. Okay. To use or to check whether they are not equal to, we use exclamation and equal to. And the rest ones, which are mathematical arithmetic operators, which are less than equal to, greater than equal to. All right. Now these operators that you can see, they are generally used for comparison or evaluation purpose. Now many a times we want to check, so from automation point of view, we want to check the URL of the website open. All right. Now, probably LHS, we would have our expected URL in a string, and we will fetch that URL from the site which is opened in the browser. Okay. And then what we will do is we will compare both of them using double equal to operator. Of course, now in Java, to compare string, we have special functions, but a simple use case of these operators are just to compare two values. Equal to. Okay. Now, these are some of logical or conditional operators. Now, in the previous slide, we saw this exclamation. Now this explanation is used for a not operation or a negate operation. When you say not equal to, we use exclamation, and hence not or explanation is used for negating values or negating the variable. Okay. Double ampersand is used for AND operation. So when I say LHS and RHS, if both are true, this entire expression equals to true. Whereas two pipes is an OR operator, where if LHS is true, this expression is true. But if LHS is false, it will evaluate the RHS. And if that is also false, the entire expression is false. Okay. To add to these conditional operators, we have a special ternary operators in Java, which is question mark and colon. Now, the syntax or the format of this operator is you have an expression or you have a condition, okay, and you check whether that condition is greater than or less than whatever it is, okay, and you evaluate. If this expression is true, this part is evaluated, else the part after colon is evaluated. Let me give you an example. I'll take, say, int a1, say 35, and I'll say int b1, say 45. Oh, so sorry. Okay. Now, what I want to do is I want to print the value of the largest number, say C1. I will say int C1 and C1 equal to, I will check if A1 is greater than B1, then you assign A1 or you assign B1. And I print the value as C1. Of C. Okay. So when I execute it, the value of C1 is 45. So what it did, it evaluated whether A1 was greater than B1, it evaluated to false. When this expression is false, the part after the colon is executed. Now the part after the colon is B1. Now this value is assigned to the LHS part. And hence we got the value as 45. So this is how you can compare and assign both in the same statement. Okay, let's move ahead. We saw the plus operator, so let's not focus on this. Okay, we have a couple of additions. Okay. Let me just give you a couple of more. Now in Java, you should always be, or rather in any programming language, you should always use bracketing for proper calculations, or to have a meaningful and correct calculations. So when I say correct calculation, So I have say A1. Okay, now I can put plus B1. Let me just put simple values so that it becomes easier. So 10 and 20. Okay, and I'll divide it say by 5. And my C1 is equal to this. Correct. Now, if I want to add these two numbers and divide, we should put the brackets and do it. Or if you want to divide first and add, you should correspondingly put the brackets and execute it. Okay, so these usage of parentheses becomes very important in these mathematical operations. Otherwise, it will generally use the BODMAS principle and calculate the expressions. Okay. Now, apart from these, there are other operators also, but which are not so widely used. They are bitwise operators. When I say bitwise operators, let me show you. So you have this as a unary bitwise operators. Then you have single ampersand for a bitwise AND operations. Now what it does is it changes from 1 to 0 and 0 to 1 for a given number. Okay, these are not so widely used in our programming language, but or rather in our automation as well, but it's just a couple of operators that you should also be aware about. Then there are a couple of other operators like signed left shift. What it does is it will move the digits or ones and zeros, the bits to left or to or right. Okay, these were all the concepts that probably you must have studied during your college days, engineering days. So these are a couple of operators that are also available in Java, and they are used in high programming languages or other high software development projects, but not so much widely used in automation projects. But as a student for Java, we should be aware about these operators. All right, I think we'll stop the session over here. We have so we've learned about variables, we learned about data types, and we also saw operators. All right, so these are a couple of the basics of Java. There is a second part of it which are nothing but control flow statements, like conditional statements and expressions. And after that we will also see something called as loops, which has for, do while loop, and then we have something called as so in control statements we will see if else, if else, if else. Okay. Then switch case. These are the couple of control statements that we will see. and then there are statements for in loops we have branching statements like break, return, and continue. So not return, continue. And of course we have return, which is also used in functions and loops. Right? So we will see these topics in the next session. We'll end the session over here.